Welcome to Mr. E Science Theater presents Introduction to Newton's Second Law. Newton's second law basically says that the net force acting on an object is equal to the mass times the acceleration. Or in other words, the acceleration is proportional to the force divided by the mass. The way this is usually done in problems is to look at it in terms of the individual forces. So let's suppose I have an 8 kilogram block on the ground and it is pulled to the right by an applied force of 50 newtons and there's no friction. The way to begin a problem like this is to begin by drawing a force diagram. So for this block is my system. I would begin with the force of gravity, because it's down. It's the only long-range force, and so I always like to start there. Then I'm going to draw any applied or given forces. In this case, I've got an applied force to the right. I'm going to call that F. And it's touching the table, and so there is a normal force perpendicular to the surface of the table, pushing upward. I call that the normal force. There's no friction. It's not touching anything else, so we've accounted for all the forces here. So step one is to draw the force diagram. Step number two is to write our equation. And the equation we're using for second law is net force equals mass times acceleration. Step three is to identify by name. Can't stress the importance of this step. The forces which make up the net force. Now to do this, I like to think of it in terms of go minus stop. Or you can think of help minus hinder, or big minus little, or however you want to think about it. The object here is going to accelerate to the right. So the forces which make up the net force are going to be right minus left. So in this case, that's going to be the applied force minus nothing. So it's just the applied force is the net force, and that equals mass times acceleration. Step number four is to plug in numbers and solve. So I plug in the applied force 50, the mass is 8, so 50 divided by 8 is the acceleration, and I get 6.25 meters per second squared is my acceleration. Okay, so that's what Newton's second law looks like. Draw the force diagram, write the basic equation, identify by name the individual forces which make up the net force, think go minus stop, and then plug it in, solve. Let's look at a similar scenario, but now let's add some friction. So we'll keep our 8 kilogram box here, and we'll keep our applied force of 50 newtons, and this time we'll say there's 30 newtons of friction. So if I begin step one, force diagram, start with gravity, then I draw any applied forces or given forces. It's touching the ground, so there's a perpendicular force, normal force, and there's a friction force, this case, that we knew, parallel to the ground and resisting motion. Now the block will still accelerate to the right, so when I do my equation, net force equals ma, that's step number two. Step one is a diagram, step two is here. Step three, as I identify my individual forces, it's accelerating to the right, so I'm going to think right minus left. So from my diagram, I can see that's F minus the friction force. So the applied force F minus the friction force, that's my net force right there. That is what is equal to mass times acceleration. Now step four, I can plug in the numbers. 50 minus 30 equals the mass times the acceleration. 50 minus 30 is 20, equals 8 times A. 2.5 meters per second squared is my acceleration, like so. Let's make it just a little bit more interesting. We'll still stick with our good old 8 kilogram box and our 50 Newton applied force, but this time let's put that applied force at an angle. Let's say that's a 20-degree angle, and we'll keep our 30 newtons of friction because, you know, it's just fun to do that. So I've got my 8 kilogram box pulled by a 50 Newton force, but this time it's at a 20-degree angle and 30 newtons of friction. So to solve for the acceleration, I would begin with step number 1, force diagram. Start with force of gravity, draw any applied or given forces. The applied force, it's touching the ground here to the surface, so there's a normal force that's perpendicular to the surface and a friction force that is parallel to the surface, like so. What direction does this block accelerate? It's going to accelerate horizontally to the right, like so. So when I do my net force equals mass times acceleration, it's accelerating to the right, so my net force is going to be right minus left, which in this case, to the right, I have a part of that applied force, so that applied force is partly to the right and partly up. The part that is to the right we call the x component of the force, or F sub x. To the left I've got the friction force, and that's going to equal mass times acceleration. Step 4 is to plug in my numbers. Okay, I don't know what Fx is, so we're going to have to find it. To find Fx, I'm going to draw my triangle. Here's my F, which is 50 newtons. Okay, and then I've got Fx here to the right, and Fy, which is up. And here is a 20-degree angle. Notice there's a right angle here between x and y. Fx is the adjacent side. And I remember that the adjacent side is equal to the hypotenuse times the cosine of the angle. The opposite side is equal to the hypotenuse times the sine of the angle. So in this case, Fx is adjacent. Fx equals the hypotenuse, 50, times the cosine of the angle, 20 degrees. So making sure my calculator's in degree mode, I go ahead and type in 50 times the cosine of 20, and I get 46.98. So I'm just going to call that 47. 47.0. So 47.0, that's my Fx minus my friction, 30 newtons, equals my mass, 8 times my acceleration.